M6.1 earthquake strikes Vanuatu. Powerful shaking rocks. Port Olry. Early Sunday morning at 3:20 UTC, the ground shifted 56 kilometers northeast of the small coastal village of Port Olry in Vanuatu. It registered as a magnitude 6.1 earthquake on the U.S. Geological Survey's network. On paper, a 6.1 sounds like exactly the kind of earthquake that should be rattling dishes off shelves and sending people running into the streets. But here's the detail that actually tells the real story, and it's the kind of detail that gets lost the second a headline reaches for the word powerful. The reported shaking on the ground was light, barely felt at all, in fact. I want to walk you through exactly why a magnitude 6.1 earthquake, a number that sounds genuinely alarming out of context, produced almost no perceptible shaking in the community closest to it. The answer is one of the more useful pieces of earthquake science you can actually learn, and it applies to a huge share of the earthquakes that happen in this exact part of the world. Stick with me to the end, because I'll also explain why Vanuatu, despite this specific quake being a non-event, remains one of the most genuinely seismically dangerous countries on the planet, and what happened there just 20 months ago that proves it. And if you want to be here for the next update on seismic activity across the Pacific, subscribe to Nymora Proof before we get into it. Let me start with the actual data, because I think laying out the real numbers first is the fastest way to understand why this earthquake didn't match its own headline. According to the USGS, the magnitude 6.1 earthquake struck at a depth of 188.1 kilometers, or roughly 117 miles beneath the surface. The epicenter sat at coordinates 14,547 degrees south, 193 degrees east. That placed it 56 kilometers northeast of Port Olry, a small coastal village with a population of around 1,300 people. The European Mediterranean Seismological Center independently confirmed the same magnitude and the same depth. That gives real confidence in the accuracy of these numbers, rather than leaving room for the kind of early estimate confusion that sometimes muddies the first reports after a major earthquake. Vanuatu's own Natural Hazards Department did not issue a tsunami warning, and there were no early reports of any damage at all. The USGS's automated pager system, which estimates likely casualties and economic losses within minutes of an earthquake based on population exposure and shaking intensity, assigned this event a green alert level, its lowest category. That specifically indicates no significant casualties or damage are expected. The earthquake was detected by 75 seismic stations, with excellent location accuracy. The USGS's own significance rating placed this event squarely in the category of routine seismic activity, not an unusual or noteworthy rupture by the standards of a region this seismically active. Perhaps most tellingly of all, official felt reports collected from the public registered this earthquake as felt by exactly one person nearby. The maximum reported shaking intensity was classified as light on the modified Mercalli intensity scale. So here's the honest, complete picture. A magnitude 6.1 earthquake struck off the coast of Vanuatu, and almost nobody on the ground actually felt it in any meaningful way. That's not a contradiction, and it's not evidence that the reported magnitude is somehow wrong. It's a genuinely important lesson in how earthquake magnitude and the actual felt intensity of shaking on the ground are two related but very different measurements. Understanding the gap between them is exactly the kind of thing that turns a scary-sounding headline into something you can actually interpret correctly. Let me explain the mechanism, because this is the real substance of this story, and it's more interesting than the earthquake itself. Magnitude measures the total amount of energy released at the earthquake's source deep within the earth. It's an absolute number, calculated from the physical properties of the fault rupture itself. It doesn't change no matter how far away you are or how deep the earthquake occurred. But the shaking you actually feel on the surface, what seismologists measure using intensity scales like the modified Mercalli scale, depends heavily on how far that energy has to travel before it reaches you. Depth is one of the single biggest factors determining that. An earthquake's energy spreads outward from its source in 3 dimensions, weakening as it travels through more and more rock. That's the same basic physics behind why a loudspeaker sounds quieter the farther away you stand from it. A shallow earthquake, one occurring just a few kilometers beneath the surface, delivers its energy to the surface almost directly overhead. There's relatively little rock in between to absorb and disperse that energy before it reaches you. A deep earthquake, like this one at 188 kilometers, has to push its energy through a vastly greater volume of rock before any of it reaches the surface. That extra distance dramatically attenuates, or weakens, the shaking that ultimately reaches anyone standing above it. That's precisely why a magnitude 6.1 earthquake at 188 kilometers depth produced shaking that registered as light and was felt by essentially nobody. while a magnitude 6.1 earthquake at a shallow depth of, say, 10 kilometers would almost certainly produce genuinely strong, damaging shaking directly above its epicenter. Same magnitude, same total energy released at the source, wildly different experience on the ground, purely because of how far that energy had to travel before it arrived. This classification, an earthquake occurring between roughly 70 and 300 kilometers deep, is technically referred to as an intermediate depth earthquake. It's a genuinely common category of seismic event in exactly the tectonic setting Vanuatu sits within. Now let's talk about why Vanuatu produces this specific kind of deep earthquake so regularly, because the answer connects directly to the country's broader and genuinely serious seismic risk profile. Vanuatu is a low-lying archipelago nation sitting directly on the Pacific Ring of Fire. That's the horseshoe-shaped arc of intense volcanic and seismic activity that wraps around the Pacific Ocean basin and produces the overwhelming majority of the world's earthquakes and volcanic eruptions. Specifically, Vanuatu sits above the new Hebrides subduction zone. There, the Australian tectonic plate is being forced downward, or subducted, beneath the Pacific plate at one of the fastest convergence rates recorded anywhere on the planet. As that slab of oceanic crust descends deeper and deeper into the Earth's mantle, it continues generating earthquakes throughout its descent, not just at the shallow boundary where the two plates first meet. That's exactly the mechanism behind this particular event, an earthquake generated within the deep descending slab itself, roughly 188 kilometers down. It's entirely consistent with the normal, expected seismic behavior of this specific subduction zone. I want to be genuinely clear about something here, because it's an important distinction and one that connects to a story I covered just recently. This Vanuatu earthquake is mechanically similar, in the broad category sense, to the massive Kamchatka earthquake from last year, both being subduction zone-related seismic events, but it's important not to overstate any connection between them. These are separate subduction zones on opposite sides of the Pacific, thousands of miles apart. There's no scientific basis for treating them as connected or as evidence of some broader escalating pattern across the Ring of Fire. Vanuatu, Kamchatka, Indonesia, and dozens of other Ring of Fire locations each produce earthquakes regularly and independently. That's because they each sit above their own distinct subduction zones, not because activity in one location triggers or predicts activity in another thousands of miles away. That said, I do want to be honest that Vanuatu's regional context has genuinely been active recently, because it deserves real acknowledgement rather than being glossed over. Just 2 days before this Vanuatu earthquake, a devastating magnitude, 7.7 earthquake struck Indonesia's Flores region. It killed dozens of people and triggered a brief tsunami warning across 4 provinces. That's a completely separate seismic event on a completely separate stretch of the Ring of Fire. It's connected to this Vanuatu quake, only in the loosest sense that both nations happen to sit somewhere along that same enormous, multi-thousand-mile arc of tectonic activity circling the Pacific. I mention it specifically to draw a clear line between the two. It would be easy for anyone scrolling through disaster headlines this week to lump every Ring of Fire earthquake together into one escalating narrative. I think it's genuinely important to resist that instinct, because these are independent geological events on independent fault systems, even when they happen to cluster within the same news cycle. Now, let me address Vanuatu's own very real seismic history, because while this particular earthquake was a non-event, the country's underlying risk is genuinely serious and deserves proper context. The largest earthquake ever recorded in Vanuatu struck on October 7, 2009, registering magnitude 7.9. That was dramatically larger and more energetic than Sunday's magnitude 6.1 event. And more recently, and more relevantly to understanding Vanuatu's actual lived seismic danger, a magnitude 7.3 earthquake struck near the capital city of Port Vila in December of 2024. That earthquake was genuinely powerful and shallow enough to cause severe structural damage, including to a building housing the American, British, and New Zealand embassies. That earthquake caused real fatalities and significant destruction across Port Vila, standing in sharp, direct contrast to Sunday's essentially unfelt magnitude 6.1 event. Placing these two earthquakes side by side is exactly the lesson I want you to walk away with from this video. Magnitude alone tells you almost nothing about what an earthquake will actually do to the people living through it. Depth, distance from population centers, and local building conditions all matter just as much, sometimes considerably more, than the raw magnitude number attached to the headline. Let me also address the aftershock question directly, because it's a legitimate, practical concern for anyone following this specific event. Aftershock sequences from magnitude 6.1 earthquakes typically continue for weeks to months following the main event, gradually diminishing in both frequency and size over that period. That's standard, expected behavior for essentially any earthquake of this magnitude in Vanuatu or anywhere else. Given how deep this particular earthquake occurred and how minimally it was felt on the surface, any aftershocks following this specific sequence would very likely be similarly unnoticeable to residents of Port Olry and the surrounding area, though continuous monitoring by the USGS will track the sequence as it unfolds regardless. So let me bring this all together, because I think the honest, complete version of this story teaches something genuinely useful that applies well beyond just this one earthquake in Vanuatu. A magnitude 6.1 earthquake struck 56 kilometers northeast of Port Olry at a depth of 188 kilometers. It was generated by entirely normal expected activity within the subducting slab beneath the new Hebrides trench. Despite the magnitude number sounding alarming in isolation, the earthquake's significant depth dispersed its energy so thoroughly by the time it reached the surface that it registered as light shaking. It was felt by essentially nobody in the immediate area, with no damage and no tsunami risk. That's not the earthquake underperforming some expectation. That's exactly how depth and magnitude interact in seismology. It's the specific reason Vanuatu, sitting above one of the most seismically active subduction zones on the planet, can experience earthquakes at this frequency without every single one of them becoming a genuine disaster. The real danger in this region comes specifically from shallow earthquakes, like the magnitude 7.3 that struck Port Vila in December 2024. There, the shorter distance between the rupture and the surface allows far more of that same seismic energy to translate directly into destructive shaking. Here's the practical takeaway for anyone living in Vanuatu or anywhere else along a subduction zone like it. Magnitude alone is never the whole story. It's genuinely worth learning to check the depth listed alongside any earthquake report, because that single number tells you an enormous amount about how seriously to weigh a specific event. A magnitude 6 at 10 kilometers deep, directly beneath a populated area, is a fundamentally different, far more dangerous situation than a magnitude 6 at nearly 200 kilometers deep. That's even though the headline attached to both would likely look almost identical at first glance. Understanding that distinction is exactly the kind of literacy that helps you tell the difference between a routine, essentially unfelt seismic event and a genuine emerging emergency, without having to wait for an official statement to tell you which one you're looking at. Before you go, I want to ask you something, because I think this earthquake is a genuinely good example of a broader pattern in how disaster news gets covered. Does knowing the actual depth and felt intensity data change how you read a headline like "Powerful Shaking Rocks a Specific Town" compared to just seeing the magnitude number on its own? Drop a comment and tell me honestly, because I think a lot of people, understandably, default to judging an earthquake's danger purely by its magnitude. And I'm curious how many of you already knew depth played this large a role before watching this. If this gave you a clearer, more accurate picture of what actually happened instead of just the dramatic version of the headline, hit that like button. It genuinely helps careful, precise breakdowns like this one reach people instead of coverage that treats every earthquake number as equally alarming regardless of context. Subscribe to Nomura Proof so you're here for the next update on seismic activity across the Pacific, because I'll keep giving you the real depth, the real intensity data, and the real context every single time. Drop your thoughts in the comments, and I'll see you in the next one.